Alright. So we are all up and running with the new database.
Yeah.
And as you probably noticed, there's a few similarities with the last task database, but also some subtle differences. And we're going to look into what those are. So if you remember, this ER diagram is from the database we had the first lesson with the 3 tables and the 2 relations. Can anyone remember what kind of relations those are? Yeah, they're both one-to-many. Exactly. So a task can have one status, but a status can belong to many tasks, and the same with the user. So now we're going to try some many-to-many relations instead. So we're basically going to change it around so it looks like this. So can you can someone say what the difference is here? How is this database different?
Here we got many to
Yeah, it's a many-to-many relation.
Associated.
Yeah, like a conjoining table.
Yeah, exactly. A joining table or
And the task can be assigned to many users.
exactly. So that's the key difference, that instead of just having a task being assigned to one user, it can be assigned to many, so you can collaborate on tasks. And of course, still a user can have many tasks as well. So that's what this table does. It's basically just a primary key and then two foreign keys. And I would say actually we don't even need this primary key. I'm not sure why it's here. Because usually when you have a table like this, you just say the primary key is the 2 foreign keys combined. Because you can never have more than one of the same pair. So like user 1 and task 1, it doesn't make sense for them to be there twice. So that's the database that we got up and running now. We can maybe have a look at how it's structured. So let me see. Alright, so the table we talked about, the many-to-many, is this one. And actually, as I talked about, here we don't have an ID, so maybe it's just the image that's not been up to date. So we have 2 columns, user ID and task ID. They're both integers, the same type, and there are foreign keys for each of the tables. And as you can see here, the primary key is the 2 foreign keys combined. That's the natural thing to do when you have a table like this. So we can try to do some queries on it to find something. Like we can find out how many tasks a specific user has, for instance. Like if we say we want all the tasks belonging to user ID 1, how would we do that? select what do we want to select?
User underscore task.
What do you need?
Yeah, we maybe just we want the task, so we can say we can do this actually, if I can spell. Task, it's singular, right? Task dot star. It's just from, and then where do we select from? From user.
What do you want exactly? User ID?
I want all the tasks belonging to a specific user. So user ID 1.
So we have to do from user.
We can do it from user, but
Or from task.
yeah, it's probably better to say from task, because that's the thing we want to end up with, the result.
From task, then you
Then we need something.
where task where task ID equals
No, inner join something like that.
Exactly.
Because you have to take user ID.
We have to join some tables. So we do inner join
User.
user on.
User.id equal to task dot user ID underscore.
But that's the way we did it last time. And then we would say where user ID equals 1, for example. If I try to run this now, it says unknown column task user ID.
Yeah, because there's a new table. The
Yeah.
task underscore user underscore task.
Exactly. So we need to do something else now. Can you figure out what we need to do?
There is
Okay.
any foreign key in user belongs
User
to
underscore
task.
Yeah. The user underscore ID and user underscore task.
Yeah, exactly. So that's what we are going to. We are still going to need a join, but instead we're going to say user task, and then I guess it's user task here as well, and then user ID, and then we should have it. Sorry, user ID. Ah yeah, we also need it here. So user task user ID. Oh yeah, of course. Sorry. This is task ID, and then just task ID, like that. Hope I didn't confuse you too much, but now we have all the tasks belonging to user ID 1.
Can you explain the code line by line?
Yeah. So basically, we just we're selecting everything from the task table.
Yeah.
So before we just did this, but this is just to be specific about it. From the task table, and then we join with the user task table, the many-to-many join table.
So, yeah.
This one.
User task.
So we're joining these two together, and then we specify that we want the user underscore task table's task ID to equal the task ID of the task table. Does that make
we
sense?
didn't specify. Yeah. It's already specified up there. Like you said, like user task the task ID. So you specified the table and the column. But equals task ID.
I think that's because we're already in task.
Yeah.
right? From task.
Yeah.
Yeah, exactly. Yeah, that's why. So we already have
If
told
you
my
said
SQL
like task ID, it would work like
task.task ID
here.
here.
Yeah.
No, because there's no task underscore ID column in task table. So maybe it's easier to see in the image, but this column is this one. So it's just called ID.
No.
And the task ID and is underscore ID is this one.
Yeah.
That's why they're different. So, but what if instead of saying where the user ID is equal to 1, I want to say where the username is equal to something. How would you do that? So if I want to maybe search for the username and find out which tasks are assigned to that username.
You need to join the other table as well.
Yeah, we need a join more. So what should I write to accomplish that? If we're so far we joined one table or one side of the join table.
And we do another inner join on the user ID.
Sure. So we can say inner join user
Yeah,
on
user task.
user task, and then which
So
column?
User ID
User ID, yeah, should equal to,
equal user.id.
yeah, and then I'll just put in where user.name, like I think there's one called something like Donald something. So this could be like a search field where we put in the username. Let's try it. Okay. So now we're getting some different tasks, and maybe I can put in the username as well, just to see that it's actually working. Now we have the name here, Donald Duck. Any questions so far?
A lot of underscore.
A lot of underscore, yeah.
It's a makes confusion.
But that's
yeah.
that's kind of the style that they chose for this database. We could also, I mean, it's totally up to you what you call these things. You could call them anything you want, basically. But it's good to have some kind of consistent.
Under is score task is a table name. Yeah.
Yeah.
But in that table, there is a command called task underscore ID. It's called.
Yes.
Yeah. Equals to then why is not task dot ID. Why is task?
It's task, the task, there is another table task. Right?
Hmm.
And then the field is ID.
So the one that's task.id is this one over here.
And you use the ID, not ID, the ID, the column, the ID.
Okay. But yeah, it's a bit confusing, but it's also just the way it's named in this example. You could call this something else, maybe something more intuitive, like user assigned tasks or something, if that makes more sense to you. That's here it's just basically the two table names put together. So let me see what else. We've talked a bit about foreign key constraints before. And can you remember what they do? What you can do with them?
Uses.
Foreign key.
With the foreign key constraints? What's the purpose of having constraints?
Because if I need to delete something, so it's not allowing me to delete it. I have a foreign key to another table in my table where I have to delete it.
Yeah. So it can protect you from accidentally deleting something. That's one.
Showing something that I have foreign key to another table, so
Yeah.
I'm
So
sure I need to delete it.
yeah. So it's like you don't accidentally delete some users if you deleting a task or something.
Yeah.
You could also tell the database that you want it to automatically delete whatever is connected to that, so
Yeah.
it cleans up by itself. There's also another property that's nice about the foreign key constraints. That's you basically it's in the name that you're constrained to some specific values. So, for example, in this example, in this table, if I want to say assign a new task to a specific user, I can't. If I want to insert into user task, and then I want to say, is it? I think it's user ID and then task ID. I put in some values. So user 1 should have task 100, for example. This won't work unless there's a task with ID 100. Otherwise I'll get an error like this. Cannot add or update a child row. You've probably seen this before. That basically protects you from putting in something that makes the data inconsistent. So you never have missing pieces.
Why would it be inconsistent in this case?
Because imagine I was allowed to put this in, then suddenly the user would be assigned a task that didn't exist.
Okay.
So because this ID, task ID, it doesn't exist yet.
Okay.
So I have to create a task with ID 100 basically.
Okay.
But I could say task 2, because I'm pretty sure there's a task with ID 2. We can look. Right, that's this one. So if I do that, it's going to work. So now that that task has been assigned to user ID 1. But if I try to do it again, I should get an error as well. Because now it says duplicate entry 1-2 for key primary. Can you do you know why that is?
Because you already insert, and if you create one more time and then double.
Yeah, you're basically right. It's because the primary key has to be unique, no matter what. So and we defined the primary key as being the two
Let's take
these
value
two
from-
together.
Yeah.
So that's why you see 1-2. So it only allows me to assign the task once to each user, and that's also a good thing. So you don't have duplicate entries. So I could say, okay, user 2 should also have this task, and that would probably work unless it's already been assigned, which is it didn't. So yeah. And yeah, we can maybe look at the table definition here to see how we specify the foreign keys for this. So of course it's this keyword constraint and then some kind of name, and then foreign key and the column name and what it references. So that's how you MySQL knows which column it's in reference to. And then this onDelete cascade part. It means that if I delete from the status table, then this row, the task, will also be deleted if there's a match. So if I deleted the status completed, then all the completed tasks would be deleted as well. That might be a good thing or it might be a bad thing, depending on what you're trying to achieve. I could also, like you said, instead we could say restrict here, and then I wouldn't be allowed to delete the status because there's still some tasks. So I would probably do that instead to make sure, but I didn't create this database myself. So, and it's the same thing down here in the join table we talked about. So we have two foreign keys, one for the user and one for the task, and they both have this delete cascade. So if I, and here it's probably the best thing to have it like this, because if I delete a user, then I also want this to be deleted. Or if I delete a task, it's the same. Does that make sense?
Makes like the data consistent.
Exactly, yeah.
Integrate.
It's always a good thing to have it on multiple layers. So you would probably also, if you were doing some Node.js, have something before you actually query the database that checks that everything's okay. All the inputs are basically validated. Because there's some things that you cannot ensure in the database, like that a word has been spelled correctly, or that it contains only uppercase letters or something. That's something you need to do in a step before you actually put it into the database. Yeah, and as I mentioned, the primary key for this table is the combination of these two columns. So that's how you write it. And you can put as many as you like. So you could imagine there was an ID more, and we could have even more foreign keys to other tables as well. Yeah. We also, sorry?
We put, like always, we put the foreign key in the one of the one-to-many relationships, right?
Yeah, no, sorry. The foreign key should be on the many side, actually.
Yeah.
So that's, I think you sometimes call it the owning side too. So it's like, for instance, task owns the status because it's the one that defines it. So if it was the other way around, like we had a task ID here, then I couldn't ever have more than one completed task, for example, or one in progress task. So it would be very inefficient to do app. So that's the way you model it. And it's the same here. It's also what this symbol kind of tries to show, is that this side is the many side and this is the one side. So here it's reverse. So we also, I think Martin talked about how to store prices and money in a database last time, or maybe it was the first lesson actually. I'm not sure.
Decimals?
Yeah, exactly. You want to use decimals,
Okay.
so you avoid the floating point errors. I think he showed some example with Node.js. So he said 1 plus 2 should equal 3. That's an integer. That's always precise. But if I do 0.1 plus 0.2 and say it should equal 0.3, then I get an error, or I get false because it's not actually 0.3. But if this was decimals, it would also be true for this this example.
What do you mean if it was decimals? So they're decimals?
No, they're floats, but that's the thing. JavaScript doesn't have a decimal type. It only has floats. Oh, what's happening? Someone took over.
Kintsugi is all about, and I think a lot of people just really connected with that idea.
Are we being hacked here? Or?
Life breaks everyone, and some are stronger in the places that broke.
Sorry about that. Don't know what happened exactly, but someone's phone took over the TV. All right. Where were we? Yeah. So. Okay. Is it maybe someone in the other class has a... Yeah. Let's try again. They should really password protect these things. I need to mention that to Christopher. Okay. But anyways, there's no floating, there's no decimal type in JavaScript. So you need to probably use some kind of library if you want to do math with money.
Okay.
Or you maybe use some other programming language, but you can sort of emulate it with integers, where you just say if you have 100, then that means like $1, for instance, and these two are cents. So if I put 1, then that's 1 cent. Then you just, when you display it on the screen, you divide it by 100. That's one way to do it. But I think there's some libraries for Node.js that enables you to do this. Yeah. Then we've talked a bit about storing dates and times and date time, and we've looked a bit at the functions for like getting the current time and stuff, and I think we also used the between to query between two times. But there's also another type in MySQL you can use instead. That's called a timestamp, and they basically look the same, but they have a different function. But you can basically just use date time all the way through, and you'll be good to go. Timestamp is just it's another way of defining it's a certain point in time, but it only represents values from 1970, 1st of January, till some time in the future. But with date time you can represent any time. So that's like if you want to do a database over historical events or something that's like really far in the past, then I would definitely use that. But that's also in the documentation for MySQL. So if you ever get in doubt, you should look there, or Google.
Google.
Always Google. And Stack Overflow as well. We also talked a bit about time zones, I think, and I think did Martin post a video about time zones?
Yeah.
I think he did. Did any of you watch it?
Yeah, that guy that was explaining the complications. Yeah, that guy.
Yeah, I think it's somewhere here.
It's pretty interesting.
Yeah, he's really good at explaining it, but not sure. Oh, that's SQL injection.
I think you already passed it way down there.
Ah, here we go. The time zones. So if you haven't seen this already, you really should watch it. It's quite funny and eye-opening. There's a lot of problems in computer science are due to times and dates and time zones, and it's horrible basically. But what you just need to know is that when you store something in the database, you always want to store it in the universal time, or UTC as it's also called. So when you get data from the user, you need to know you need to know that you get it in local time, and then you can convert it to UTC. And then once you display it again, you probably know which time zone the user is in, so you can convert it back. But then everything's consistent, and no matter which, like if you have different tables with dates in, you can still compare them because you know it's always the same time zone. So there's never any overlaps or any weird stuff going on. Yeah, I guess we're closing in on the break, but if you have any questions to the material so far, you can just shout it out. Alright, I think we'll save this for after the break. But we can do some more queries maybe on the new database. Like we could continue on this. What could we query for?
Join. I think the joining. Yeah.
The join is it's the difficult one.
Yeah.
We get
Everyone.
another example like left join or right join.
Left or right join? Okay.
What joins do you use in the real world environment?
In the real life, yeah.
Like
You almost
what's your first say to you?
you almost always use inner join or left join. That's the two you really need to know.
Left, yeah.
Because right join is just left join flipped around.
Yeah.
So it's just it's basically the same thing. But I think there's also a pretty good illustration of it in the lesson 2. You can go into the lesson 2 folder on GitHub. Or I can just post it for you. Oh, sorry, is it lesson 1? Yeah, this one, this PDF. It has all the different types of joins you can imagine. But I'm not sure if GitHub wants to collaborate today, so let's see. Yeah, this one. So basically what we have been doing so far mostly is inner join, where you just say I only want the data that exists in both tables at the same time. And then left join is where you say I want, for instance, I want all the tasks, including the ones that have no user assigned. So you get nulls on the other side. So on this side, if there's no match, then you just get null values instead. And then of course right join is the same, just flipped around. So you don't really need right joins, because you can just type it so it matches a left join, and then so it could be something like maybe select from task and then join the user and say basically just join without any conditions. So some places the user would be missing. That's the differences. Then the full outer join, I wouldn't worry too much about it. It's basically a combination of every possible combination of rows between two tables. So it's not really applicable for most things. It's more like for math stuff, I guess. Yeah, you can also see it here with the left join. You have the username and the title of the task, and then these two users have no tasks, so it's just null. So did that clear it up? I guess we might be able to modify some of these if we had a query. I guess it's not really left join. It's not really that useful when you have many to many, because you need a match in the join table in order for it to make any sense, I would say. But you could imagine if a task didn't have any status, it would be null. So you could join them, and then you would just see null for the status name. But what could we do for a query here before the break? In this one we queried all the tasks, but we could also do it the other way around, or we could say how many completed tasks does each user have, maybe. That's a bit more complex.
How many completed tasks?
Yeah, you would probably need to also join in the status table.
Yeah.
If you want to say like it should be equal to the string completed or done, or yeah. So so how would I write it to get that? So I want to select account, right? Yeah, of task.id from task, right?
Task user version, right? Between user and task, or between
yeah, you're right. We actually besides the count, we also need the user. Should we say the username?
Yeah.
So we need to join the user to the task table. So that's going through the other table.
User task.
Yeah. On
User task. The user maybe or task ID.
yeah. Task ID equals to task.id. So that's the same as we had before.
Yeah.
And then
You have to enlarge it again. From status.
yeah, we also need the user.
Username, yeah.
Yes,
From
exactly.
user.
So exactly.
On user task user.
Yeah, sorry. Yeah, user task dot user ID equals to
the user dot ID,
mhm.
and you have to inner join again, but between task and status.
Yeah, so we can get the status name.
Yeah.
So we say inner join again.
From
Status, yes. On. Then what is it?
I think there is only a relationship between task and the status, right?
Yeah.
So between task dot ID
Task dot.
not the status ID.
Yes,
Equals status dot ID.
exactly.
But you have to group it by something. You have to group it by username, right?
Yeah. You're right. So
Because
so
you need to make a group and like in the left you have to have the one.
So also we said that we would only the tasks that are completed, right?
Yeah, where
So we say task name. Oh, sorry. Status. Yeah.
equal them or write them.
Is it title or name?
Name.
It's name. Name equal to completed.
Done.
Done. And then, as you said, we need to group by user.name, or we could also just say user ID.
Yeah.
It's pretty much the same thing. Okay.
Why did we group them?
Because he said how many years, how many task issues are like have, right? Or
Yeah.
have done.
Yeah, per
Something
user.
like that.
So it's like saying per user. But it's probably more clear when we do this. So you can see if we didn't group by, we would only get one row with all the. So that would be like just
And
counting
if
all
we
the.
need to order by something, so we get like descent or if we need to like get first the user have most tasks done.
Yeah. So you want to order by the count?
Yeah.
Yeah. We can do that.
Descent.
Yeah. It's something with the descending ordering. So how would we do that?
Ordered by count and I do something like that.
So
All the functions
count
and
task.id
yeah.
and then descending,
Descending and will give us.
and then exactly. Then we are ordering by this count. One thing that's nice to do when you're doing something with count or min or max or some aggregate function, as they are known as, is to specify an alias as, and then something like we could say
Tasks completed.
yeah, tasks completed. Completed. Because then I only need to mention this once, so I can down here I should be able to just say tasks completed like this, and it should give me the same result. Plus we get this nice name up here. But also it kind of makes sense to say like order by tasks completed descending. That's more logical than saying order by count task ID, and you're duplicating logic because we can only define this once. So yeah, exactly. Don't repeat yourself. It's a good mantra. So nice. That was a pretty complex query. So I think we should just leave it there and maybe.
There is this website SQL Zoo.
SQL Zoo.
Yeah. It has the word. Yeah,
Dot-
has the word database, and there is like quizzes for everything.
Oh, nice.
Very useful.
Yeah, we can maybe do some of the quiz things. I'll just have a look at it and then
So it's very useful, like to say like which population and this stuff.
Mm.
Cool.
Ah, yeah. So you can select the correct answer and okay, that's really nice. Have you done some of the?
Yeah, I've done this one. I learned it here.
Okay.
Quiz.
Cool. You know what? I'm just gonna post this. This is a really nice.
Is it built on the Wikipedia?
Yeah, I think so. It's the wiki, media wiki or something.
You can download it if you want, like the database of the world.
Oh, okay. So you can run it there locally. Okay.
This is not the big countries.
So you need to read the database first, see how many columns they have, what they have. They have also many other things.
That's cool. I'm gonna actually go through that.
Thanks for that link. That's really nice.
So you
Okay.
got like the countries from Asia or something. The countries from Asia with population